So, look at it here. Solve the following inequalities. Yesterday we do at this point, and today we are discuss the last question of the exercise 1.2. Basically, this is our exercise 1.2. And this is our last solve the following inequalities. In previous sessions, we were studying the quadratic equations, their quadratic functions, and quadratic equalities. But in this question, we are studying the inequality, quadratic inequality. So this is the our x here minus 6 of x plus 5 is greater than 0. Solve the following inequalities. So there is the same method. In this manner, we are solving the equalities, and we are solving the inequality in the same manner. So here we have the same three methods. One is quadratic formula of factorization and completing this here. Look at it here. We are making the factors. Uh, the factor is minus 3 of x and minus 2 of x. This is the plus 5. So look at it here. Uh, is greater than equal to 0. Look at it here. If we are checking our pair, if we are adding, this is the minus 3 of x. But check it, CK, if this pair is okay or not. Here we are checking this pair is minus 3 of x minus 2 of x. When we add it, this is the minus 5 of x. Okay, so look at it here.
Yeah.
This is not okay from this one situation, because if we are we add this, we have this one, and if we are multiplying this one, so this is the plus 6 of x. It's mean this pair is not okay. In this sense, we are checking our pair is which one is best or suitable. Okay, so before of the this one, we want to try the more pairs. We want to try the more pairs. So this is multiplied by this is the our 5 of x square. Here I'm writing this is the 5 of x square and minus 6 of x. So we want try this one. 1 multiplied by 5. This gives us the 5. So I'm setting the pair. This is the minus of x minus 5 of x. So it gives minus 6 of x. This is, and same for if we are multiplying this minus x and minus 5 of x, this gives us plus 5 of x. Okay, so this pair is okay. This pair is okay. So our pair is what?
Yes, sir.
Minus x and minus 5 of x plus 5 is equal to 0. So from this one, we are taking the x's as common. So if we take the x as a common, so this is the x minus 1. And from this, we are taking the minus 5 is common. So this is the x minus 1. And from here, we can we are see that our factorization is okay. And now we are taking the common. Sorry, we are making some mistake, because this is the greater than 0, so I'm writing the greater than 0, because this is our inequality, not equality. So x is greater than 0. This is the x minus 5, and this is our x minus 1 is greater than 0. So from this one, our x minus 5 is greater than 0, and here we have the two cases greater than 0. So this is gives us minus 5 is moving to the other side. This is the plus 5 and then greater than. Also, this is minus 1 is moving to this side. X is greater than 1. So I'm writing the our answer is in between this which format. So our axis belongs to the greater than 5 and greater than 1. So 1 is less than x is less than 5. So I'm writing the final answer in this format. Can you understand it? How am I right, or what I'm trying to say?
Yes.
Okay. Okay, from the sixth one part, these are the same, but I am moving to the E part of this one. This is the 8 minus 2 of a is greater than or equal to a square. And look at it here. In our quadratic equations, we are depending upon the a square. We are depending upon the a square. Our a square is negative. Our parabola open downwards. Our if a is positive or a square term is positive, then our parabola is open outward side. So from this one, in this situation, look at it here. We are moving to the other side. So this is the a square. This is the plus 2 of a. This is the minus 8. So this is also greater. This term is also greater than 0. Okay. So in this point, mostly student can be confused or they can mix up them and they can rearrange, and after the rearranging they can reduce this one, but in that manner this is not reduced. Why this is not reduced? Look at it here. Our a is look at it here. Our a is positive, so this is greater than 0. If this is the negative, if this one is negative, so this will term this whole expression will be less than 0. Okay, got it?
Okay.
So, from this one, our if we are comparing our equations, if we are comparing our from this one, can you check what is our first we are checking the pairs. If we can do the factors, then this is okay. Otherwise we are moving to the other method. So this is minus 8 of square and this is the 2 of a. If we are multiplying, this is the minus 8 of a, and if we are setting, this is the 4 2 of a. So from this one we have the 2 multiplied by 4. This is the a. If we are setting, if we are no we are setting, this is the minus 2 of a, and this is the plus 4 of a. If we can add it, this can be the 2 of a. If we are setting minus 2 of a multiplied by 4 of a, this gives us minus 8 of a square. So check it at here. Our this pair is satisfied our both equation. That's why this pair is okay. Now we are making the a square and minus 2 of a, and plus 4 of a, and minus 8 is greater than 0. So from this side, if we are taking a is common, this is a minus 2, and from this side we are taking the 4 is common. We are taking the 4 is common, so this is the a minus 2, and also this is greater than 0. Got it?
Yes, sir.
So from this one, a minus 2, we take the common. A minus 2 is common. So our a plus 4 is greater than 0. So a minus 2 is greater than 0, and a plus 4 is greater than 0. And minus 2 is moving to the other side. This is a is greater than 2, and this is moving to the other side. This is minus 4, and here our sign is change. Okay, can you tell me why I can change the sign in this situation? In here we have the greater than sign, but here I'm put the negative less than sign. Why I put it? Can you explain it, or can you know about this one? Why I can do it?
No, sir, I don't.
Okay, so look at it here. This is the a plus 4, something plus 4. It's mean something is doesn't matter. Something plus. It's mean we are adding. It's mean our answer will be always greater than 0. When we are something minus 0, are we moving to the other side? So this is something is less than 0 because we are not knowing this one is okay or not. Because look at it here. In this situation, in our this expression, this on the behalf of this one, we are saying that a plus 4 is always greater than 0. But plus 4 is moving to the other side. This is minus 4. As you know, minus in minus terms, the number is increases, but the value of the negative number is decreases. So here I'm decrease the sign rather than putting the increasing sign. So I'm writing this is the minus 4 is less than s a and a is less than 2. Got it?
Yeah.
Is there any confusion from this one problem?
No, sir, no confusion.
Okay. So and this one point is clear why I am putting the greater than or less than sign. Okay.
Yes, sir.
Okay. Okay. No, this is our the practice past paper questions. Express our express our equation 2f(x squared minus x plus 6) in the form of p into x minus q of whole square plus r, where p, q, and r are the p, q, are the constants to be the found. Constants to be the found. So our question is what? Again, read. Look at it here. This is the
I'll do this, sir. I'll try doing that.
okay. Look at it here. This is the 2 of x square minus x plus 6. But from here you can note that this is the square. Our answer is in square format. Basically, indirectly, our examiner can want or can be bound us to follow the completing the square, to follow the completing the square. Okay, so from this one side, this is equal 2 of x squared minus x plus 6. So I'm taking the common from this side is 2. This is the x squared. Why I am taking common? Look at it here. This is the sum p. He is defining p, q, and r are the constants to be found. So x squared, this is the minus x over 2 and plus 6. Understand?
Yes, sir.
Okay. Now we are moving to the our completing the sukir. We are moving to the completing of sukir. So our completing sukir is what? A plus b whole sukir is equal to a sukir plus b sukir plus 2a of b. So in this format, in this situations, this is our x square minus x over 2. It's mean our x over our minus minus 1 over 4 of square. It's mean minus 1 over 4 of square we can be add. Why we are add the and in subtract? Look at it here. This is the 1 over 4 of square. Add and
Yeah.
plus 6. Can you explain it? Why I am adding the plus 1 over 4 square is add and subtract, or how can I know we can add this one term?
Um,
Mhm.
well,
You
identity, right?
No, you can check it again back. Basically, I'm working the on the this one pattern. Here we have the first term is this one and 2a or b are this one. So from this one, if suppose that this is the x over 2, it's mean our term is this is the 2 into x, because this is the first term is x and 2 is formula, and it's mean if we are setting 1 over 4, so this gives us the 2. So this is the x by 2. This is the x by 2. So on the behalf of this one, I'm knowing that 1 over 4 is add and subtract. Understand?
Yeah.
So look at it here. This is look at it here. This is on the behalf of this one. We are saying that 2 into our x minus 1 over 4 of whole square, and this is minus 2 into 1 over 4 of square plus 6. Can you understand how I am write this one step?
Yeah.
Look at it here. I'm just making the completing of the square on this term, and this one two, this two, and this one is, this is the multiplying, so I'm taking it outside, and this is the plus 6 is as it is. This is as it is. So no, from there, here we take the some simplification. This is x minus 1 over 4 and minus 2 by 16. 1 over 4 whole square, this is the 2 by 16 plus 6. So this is the 2 by 2 cancel to the this. So 18. And this is the 2 into x minus 1 over 4 square minus 1 over 8 plus 6. So now from here we are taking the LCM. This is the 2 into x minus 1 over 4 of square. This is minus, this is minus. So here is our LCM is 8, 1 plus 6 multiplied by 8. So it gives 48. It gives the 48. Okay, and now from this one, and this is our if we are solving this one is separately, this is plus 1, this is minus 1. Can I take it? Because this one term is minus. Here I am rearranging it. If for your more understanding, for your more simplification, this is 2 into x minus 1 of 4 of square. This is the plus 6, and this is the minus 8. Okay, now you can understand it how why I am putting the plus and this is minus 1. Can you understand it?
Yeah.
So after this is our 2 into x minus 1 over 4. Also here this is plus 47 by 8. 47 by 8. So from this one, our question was what? Our question is this equation is in the p into our question was what this is the p into x minus q plus x minus q whole square plus r in this format. Look at it here. Our answer is in this format. This is the p. From here, p is equal to 2 and q is equal to our q is equal to what? This is on the behalf of this one, and this is our q is equal to 1 over 4, and our r is equal to 47 by 8. Can you understand it?
Yeah.
So now we are moving to the our second part of this one problems. Hence, state that the latest value of the 2 of x squared minus x plus 6 and the value of the x at which the occurs. So from this one situations, here we want to discuss us asking about the value of the x. He want to know the value of this one positions. So can I write this one? If I'm taking this one equation, this is 2 into x minus 1 over 4 of square. This is the 47 by 8. So this is the second part of the same questions. Basically, he want to discuss or asking about the value of the x. And we are studying about the x, so I'm writing the this one term. So this is the x minus 1 over 4 of square. A square of any real number is always greater than or equal to 0. As you know, I'm already explaining you the square term will be the always in positive, will be the always positive. So it's mean positive mean it's always greater than 0, or maybe it is equal to 0 but it is not less than 0, or it is not equal negative quantity. So on the behalf of this descriptions I am writing the this term is always greater than 0. Can you understand it?
Yes, sir.
Greater than 0 and equal to 0. This term is always, this is in general, keep it in your mind. When we have the secure terms may be equal to 0, or maybe greater equal to 0, or always greater than 0 but not less than 0, but can't be the negative. As you know, negative term of the secure will be the converted into the positive, will be the converted into the positive. So from this one side, from on the behalf of this side, you can write this one line that I'm saying you secure term always greater than 0. So I'm taking this one, and then we are writing the x minus 1 over 4 of secure is equal to 0, is equal to is equal to 0. And the this is when 2 is moving to the other side. So this is x minus 1 of 4 square is equal to 0. Again, you are taking the under root on both sides, and here is we are not using plus minus because this is the 0. So this is cancel out. This is x minus 1 over 4 is equal to 0. So our x is equal to what? This is 1 over 4. Okay, so got it? And
Yeah,
mostly students can be confused about this term. What will be this term? Because
yeah,
I'm not using this term. Why? Because in our question, if I'm going back to our question, where you can read the question again carefully. Hence, this state that the latest value of the 2 of x square minus x plus x, and the value of the x always at which this occur. So it's from this one side. This is the extension of the x. Sorry. This is the extension of this is the extension of our x. So on the behalf of this one, we are saying that the latest value of the least value of the x is equal to 47 by 8. 47 by 8. Got it?
yeah,
Okay. Okay. Now we are moving to the our other problems of the exam times. Exam. Find the set of the values of the k for which the curve y is equal to 2 of x square plus k of x plus 2k minus 6 lies above the x-axis for all values of the x. For all values of the x, basically, what we want to find the values of the k. We want to find the values of the this is our question and two. So this is our y term is what? This is the here 2 of x here plus k of x plus 2k minus 6. K of x minus 6. Okay. So basically this is our 2 of x here. Okay, look at it here. This is the positive term. This is always on the behalf of this one. We are saying that this is open upward because this is our positive. So this is the hyperbola. This is the hyperbola or open the upwards. So on the behalf of what A is equal to 2, B is equal to K, and C is equal to 2K minus 6. How I am writing B, as you know, A of x here, the B of x plus C is equal to 0. We are comparing these equations. So on the behalf of this one, basically find the set of the values of the K for which the curve lies above the x-axis for all values of the x, for all values of the x. So here this is our discriminant d is equal to b square minus 4a of c. So our b square, this is the k of square minus 4a of c. So 2k minus 6. Now we are basically we want to find the values of the k. So from here this is our k square minus 8 into 2k minus 6. So this is the k square minus 16 of k, and this is the plus 48. Okay, got it?
Yes, sir.
Okay. Now from here we want to find the values of the k. So we are using the factorization method. So as you know, this is the 48k square. So we are setting the pairs that is 48 of the k. So I think so their pair is 12 and 4. Their pair is 12 and 4. We are setting k square minus 4 of k minus 12 of k plus 48 plus 48. So from here we take the k is common. So k is if we are taking the k common, this is the k minus 4, and from here we are taking the minus 12 is common. This is the k minus 4. So from this one k minus 4, we are taking the k minus 4 is common. So this is the k minus 4, and this is the k minus 12 is common. So on the behalf of this one, we are writing what we are writing. Uh, we are writing this is less than 0. So k minus 4 is less than 0, and k minus 12 is less than 0. So check it here. This is k minus 4. 4 is moving to the other side. This is the less than 4. Also, this is the minus moving to the this side. This is the 12. Okay, understand?
Yeah.
So, is there here you can ask these two questions. You may be the ask. First one is why I am putting the less sign, and here why I can't change the less sign. Less sign is remains same. Why I can't change it, and why I can't change, and if I change it, and why I can't put the greater than sign. First of all, here our situation is what our situation is for the curve to the lie above the x-axis, to lie the above the x-axis. That's why I'm setting x our discriminant is, so that's why our discriminant b square minus 4a of c is less than 0. That's why I'm using this one factor. And second one is k minus 4 is less than. When we are saying that the minus term is less than, this is okay. And when we are moving to this side, this term is converted into the positive. It's mean this is always it's mean in general this term is less than 0, and when we are adding in some terms in 0,
Yes.
sometimes in 0, that's why it is always remain same. Okay. So from this one we are writing 4 is less than k, k is less than 12. Is there any confusion?
No, sir, no confusion. I understand now.
Okay, now I'm moving to the our last one problem of this one of this one part. So, read this statement carefully. Our exam questions are very easy, but their statement are little bit tricky. Okay, the line y is equal to mx plus 2 is the tangent to the curve, and this is the curve, and this is the tangent of this one equation. Find the possible values of the m. So here y is equal to what? We have the m of x plus 2. This is the I'm writing it. This is the our tangent, and y is equal to x square plus 12 of x plus 80 plus 18. This is our curve, and our question is what we want to find the values of the m. So on the behalf of this one, look at it here. This is our equation 1, this is our equation 2, and the both two equations have the one side is same. So on the behalf of this one, we are writing the we are writing what? Our writing that x square plus 12 of x plus 18 is equal to m of x plus 2. M of x plus 2. Got it? And then we are rearranging the equations to the other side. This is the x square plus 12 of x minus m of x plus 18, and this is minus 2 is equal to 0. Got it?
Yes, sir.
No, from this one, our x square is common. No, from this side, plus our x is common. This is the 12 minus m, 12 minus m. This is the plus of 16 is equal to 0. Is equal to 0. Now we are discuss that a is equal to our 1, b is equal to 12 minus m, and c is equal to 16. So our discriminant is equal to b square minus 4a of c. So b square is equal to what? 12 minus m of square minus 4a of c is 1, and c is our what? This is the 16. This is 16. Now we are, this is equal to 0. We are setting these are the equal to the equal to 0. And for your for a tangent, okay, and why I'm setting the 0? Because for the tangents here I'm writing for the
Yeah.
due to the tangent condition that is always that is given in our question. That's why we are using our discriminant is equal to 0. As we already discussed in previous sessions, we don't know about the discriminant. We have the three conditions on the discriminant. You are already know delta is greater less than 0, greater than 0, and equal to 0. Why I use this one situation at here? Because of this one for the tangents of the line. Got it? So,
Yes.
so from the here, from the here, this is our 12 minus m of whole square, the whole square, and this is the 4 multiplied by 1, 4 and multiplied by 60. This is the minus 64 is equal to 0, and this minus 64 moving to the other side. This is the 12 minus m of square is equal to 64. Now we take the under root on the both sides of this one. Okay, and this is look at it here. This square and this is cancel out. This is the 12 minus m is equal to plus minus 8. Okay, got it. And
Yes.
here we have the two cases. This is the 12 minus m is equal to 8, and 12 minus m is equal to minus 8. So if I'm rearranging it, minus m is moving to the other side and 8 is moving to the other side. 12 minus 8 is equal to m. So m is equal to what? This is equal to 4, and
Yes.
when this is moving to this side, this is the 12 minus. plus of it is equal to m. So if we are arranging it, this is the 20. Here we have the two values of the here we have the two values, m is equal to 4 and m is equal to 20. Is there any confusion?
Yes. No, sir.
Okay, so this is the equation is line and the curve, and equation is line and the curve, and rearrange from the quadratic equations, and we can put it, and in this manner we can find the values of the app. So on the behalf of this one, our chapter 2 regarding the quadratic equation is ending. Okay, and today we are discuss the past paper of the questions as much, and in next sessions we will also discuss the past paper or past example as much as we can do regarding our questions paper, because we are studying or we are discussing, we are follow the exams paper. Okay, but before going to the exam paper, the book reading, follow of the book is very mandatory, very compulsory. If you know the book, you know the knowledge of the book, then you can fulfill your exam preparation, you can attempt the exams easily. Okay.
Okay, sir.
Okay. uh, okay, please rejoin the meetings.
Sure, sir.